So welcome to my live stream this afternoon. And this afternoon I'm going to discuss one of the topics about the databases. Okay, so the topic that we're going to discuss this afternoon is about the entity relationship models. So entity relationship models is very important in databases. For me, it is very essential because when you know how to model the database, how you plan it, then you can be able to create a good design and eventually a good database. So what is basically an entity relationship model? So when you say model, you are going to create an entity relationship diagram. So an entity relationship diagram represents the conceptual database and it depicts the real-world database components. So it means that these concepts here in our ERD are the real-world database components that is referring to what is in the real world. So if it is a mini world of university, so you're going to depict what are those conceptual concepts with regards to the university, such as students, we have faculty members, and then we also have subjects, departments. So in ERD, it has three components such as entity, attributes, and relationships. So entity represents a real-world object. So any real-world object in the real world is called an entity. And the one that describes the attributes, the characteristics of that entity are called attributes. So those attributes provide the characteristics of the said entity. And we have here the relationship that serves as the associations between the entities of the entities in our real world. So now let's go to each one of those representations in our database concepts. So now let's go to entities or entity. So entity is a noun and it should be in capital letter. And we have here strong entity types. These are entity types that are called regular entity types. So for example, we have here employee. We have also student, if it is a university database. If it is in the airplane, we can have flights as one of a strong entity type. It is called a regular entity if it has its own primary key or it has a key of its own. But there is another one which is a weak entity. These are entity types that do not have their key attributes. So they are dependent on the existence of the other entities. So just like what we have in our example, we have here employee has dependent. So the dependent here is the weak entity because the dependent cannot exist without the employee. That's why it's called existence dependent. It cannot exist without the relationship to the strong entity, which is the employee. And this weak entity cannot stand by its own. That's why it's called existence dependent. So this dependence here, if the employee will be gone in that particular company, so the dependents also are dependents on the employees themselves. Okay, now let's move forward to the attributes. So again, the attributes are the characteristics of our entities. So there are different kinds of attributes. We have the number one, which is the required attributes. So the required attribute must have a value and it should not be empty. The required attributes can be the name of, for example, we have employee, the employee ID. We have the name of the employee. If it is a student, we have student ID, and we have also student name, student address, the birth date of the student. So everything that describes the characteristics of an entity is called an attribute. We have also optional attribute. So if we say optional, it means that it could be left empty. It can have an empty value because of the three reasons. For the optional attribute, there are three reasons. Number one, it is unavailable, just like imp middle initial, unavailable because there are other people who do not have middle initials themselves. And then we have the optional, it is not applicable for all. And we have also not available, or it's not available at that time. Okay, for our attributes, we have the domain. So the domain is a set of possible values. So for example, if we have the sex, we have female and the male. So with that, we expect that the value for the sex would be male and female. And we have the GPA that would range from 1 up to 5. So if you have a name of the person, you can expect that it is um, it is having a number or character strings. Okay, identifier. Identifier is called the primary key. It is an attribute that uniquely identifies each entity instance. So when we're going to consider a real-world scenario of databases and we have the entities, each entity has its own uniqueness. And to hold that uniqueness, the attribute called primary key is the one that identifies it. So for example, we have here emp ID. So the emp ID now is our unique attribute. It should be unique so that it could hold the uniqueness of all the instances in your table. So if it is employee, what do you think is the primary key for that? Yes, you're right. That is student ID. If it is flight, we have flight number. So it depends on the specific entity that we are talking. So now let's move forward to the other things about attributes. We could also have composite identifier. So composite identifier, it is a primary key that is composed of more than one attribute. So it means that two attributes or three attributes now composes your primary key. Now let's move forward to the simple attribute. So simple attributes are attributes that cannot be subdivided. So for example, the last name. So for our last name here, it cannot be subdivided because um, there is no more other categories for that. So that's why it's called simple attribute. For example, we have the civil status, that is also a simple attribute. We have also the we can also have the sex as our simple attribute. Now let's move forward to composite attribute. It is an attribute that can be further subdivided to yield additional attributes. So for example, we have emp address. The emp address is called composite attribute because it can be subdivided into additional attributes such as city, state, others have zip code, others have barangay. So that is why it's called composite attribute. So that is an example of a composite attribute. And we have also single valued attributes. Single valued attributes can have only one single value. That's why it's called single valued. So example here is the sex. That's why it's single valued because we can have only male or female. On the other hand, we have multi-valued attributes. These are attributes that can have many values. An example for this is car color. So why it is called multi-valued attribute? Because of course, a car can have many colors. So a car could have three colors, combination of white, gray, and black, or maybe a car with a rainbow color, if that would be okay. So that's why it's called multi-valued attribute. And we have also a derived attribute. These are attributes that are calculated from the other attributes. So an example is emp age. Why it is a derived attribute? Because we can calculate the emp age through the birth date or emp birth date. So that's why it's called derived attributes. So can you think of other examples of derived attributes? So if you're thinking of number of employees for a specific company, that could be a derived attribute that can be derived from counting how many are the employees of that specific company. Now let's go to relationships, the third concept in ERDs. So relationships should be active or passive. It is represented by this. So if relationships the in the Valentine's or in the love month, it is represented with a heart shape. In databases, relationships is represented in diamonds. Okay, relationship degree is the number of participating entities in an association. So we have different kinds of relationship degrees such as unary, binary, ternary, and even inary. Okay, what is unary all about? Okay, it exists when an association is maintained between a single entity. So for example, we have here employee supervises employee. That is unary because the association is between or not between but within its own. So si employee is having a relationship to employee because the employee also supervises other employees. And we have here binary. So binary exists when two entities are associated. So just like this example, we have here employee manages department. So there are two entities associated with each other. So as you can see, we have here our relationship name. And we have here the ternary, which exists when three entities are associated. So we have here example, suppliers supply part to the project. So there are three entities that are involved in this relationship. So that is relationship. So there are different constraints in relationships. So what are these participation constraints? So participation constraints explains if it is total or partial. It is total if it specifies whether the existence of an entity depends on its being related to another entity type. So just like this one. So existence dependency, it means that E2 or entity 2 should participate in the relationship. All of the instances in entity 2 should be participating in the relationship because it's total participation. And on the partial participation, on the other hand, it specifies that only some part of the set of the entity are related to some of the other entity, but not necessarily all. So this means that here, the entity 1 is not required to have a participation. Not all of the entities in entity 1 should be participating in this relationship type. So that's the difference between the two. So when you're going to consider how or when to use total and when to use partial, you should ask yourself, is this dependent or is this required that all of the entities here should be participating? If that would be the answer, then you should choose total participation. But if it is not required, you can go for the partial participation. Now let's move forward to cardinality ratio. So for the cardinality ratio, we have three. We have one-to-one, one-to-many, and many-to-one. So we have here examples. So for the one-to-one, we have here example 1. Employee manages department. It is one-to-one because one employee manages one department. And one department is managed by one employee. That's why it's one-to-one. And then the next one is one-to-many. This one-to-many, for our example here, we have customer places customer order. So customer can place many orders and one customer order is placed by one customer. That's why we have one-to-many in general. And then we have the many to one. Not this is many, that is many to many. So student belongs to student organization. So student can have many student organizations, and one student organizations can have many students in it. So that's why it's many to many. Okay, moving forward, we have here the identifying relationship type. So identifying relationship types relates the weak entity type to its owner or identifying entity type. So we have there our discussion about weak entity. So the one that connects our weak entity to the strong entity is called identifying relationship type. Okay, so the owner of the weak entity type is the strong, and they are related with each other through an identifying relationship type. So the weak entity type always has a total participation constraint. Since it is dependent existent, it means that it should always be dependent to the strong entity. So that's why um, we should always be careful also when to determine that it is weak or when it is strong. So those are the things about ERD or entity relationship diagram. So those are the symbols and the concepts that we're going to learn. And in the next videos, we are going to learn on how to create an ERD from a business rule or from a company, a real world company. So thank you very much for watching, and please don't forget to subscribe and also to share this video to other who might learn from this video. So thank you very much. This is Miss Lane Diaries. Have a great day.